Good afternoon, everyone. Thank you for being with us for this talk. So I'm Michael Barbero, and this is Frédéric Gour. We both work at the Eclipse Foundation. And today we will show you a bit how we manage hundreds of Jenkins instances for projects. But first, we'd like to tell you a bit about what we mean by managing Jenkins instances. So we are basically provisioning instances for our project. We are handling backups. We are setting the tool. We are configuring the plugins, managing updates, upgrades, creating credentials, managing credentials, and also managing the interaction with all third-party services, GitHub, Maven Central, publication, and stuff like that. So quite a bunch of stuff to do for more than 200 Jenkins instances. As you can see, our users actually, they deal with the jobs. They create their pipelines and stuff like that, and we just give them a hand when they need to. So, first of all, who knows what is the Eclipse Foundation? Okay, just a couple of you, a few of you. We are not selling sunglasses. So you would be amazed how many mails we got last year asking us how they could buy sunglasses for the solar eclipse. So no, we don't sell that. Maybe you know the Eclipse Foundation or the word Eclipse a bit more for the Eclipse IDE, the Java IDE or the PHP, C++ and IDE. But the Eclipse Foundation is actually not only about the Eclipse IDE. The Eclipse Foundation, it's an open source software foundation, and we provide a platform for open collaboration and open innovation. So we basically provide a framework for companies and open source projects to collaborate. And besides the Eclipse IDE, the one that you may know the most, we actually have host more than 350 projects. We have 1,500 committers, and about 300 now corporate members. So the framework that we provide to our project is composed of four main parts. The first one is IP management and licensing. So we provide our own open source license, which enable business open innovation. We also provide governance and processes. That is tightly linked to IP management and licensing. So, for instance, when you do a release, we have a process for project to actually provide a list of dependencies that they have, and we have lawyers at the foundation that actually check that all the licenses of the dependencies are compatible. So we know that a release, that an Eclipse project release is actually IP safe. So we do community development. We host some conferences like Jenkins World, of course we don't host Jenkins World. It's called EclipseCon. And we also provide infrastructure, and that's where Frédéric and me, we are mostly involved. The focus area of the foundation, besides the IDE's technologies, are very various. So from Internet of Things to Java runtime and automotive recently. We have a bunch of strategic members, so we are a member, not-for-profit organization based on membership, and we have those, I think it's 12 strategic members, which think that the Eclipse Foundation is strategic for them and want to be involved in all the decisions. But we have many more of them, and maybe your company is actually a member and you may not know. But enough talking about the foundation by itself. I told you that we provide an infrastructure to our project, and more especially, we provide a build infrastructure, and Frédéric will explain to you a bit where we come from and where we are today.
Thank you. Thank you, Mikhail. Does my mic work? Yes, okay. So yeah, thank you. I want to just give you a bit of a glimpse into our history with regards to our build infrastructure. And in 2009, we started with a single Hudson instance. At that time, it was still called Hudson. And it was maintained by the community. And since this got some traction and was used a lot, there were more instances added. Actually, in 2010, there were 3 dedicated machines, 1 master and 2 slaves. And instead of the community the Eclipse IT team maintained them. And in 2011, more slaves were added. There were more jobs running on the machine, and there was also a dedicated master only for performance tests for the Eclipse platform project. And also in 2011, the Hudson project joined the Eclipse Foundation, just shortly after Hudson and Jenkins kind of went separate ways. And in 2013, since there was just only one main instance, it became apparent that this would not scale for many projects that were interested in doing CI. And so the Hudson instance per project initiative was created called HIP. And it was part of the so-called Common Build Infrastructure initiative that we have, where we just bundle a couple of best practices and tools that we provide to our projects. There was still one shared instance where slaves for Windows and Mac were attached, because we could not provide it to each project individually. And so this served us quite well for a couple of years. But in 2016, it slowly became apparent that the Hudson ecosystem was not catching up. There were no more commits. Plugins were not updated anymore, and the compatibility to Jenkins was just not there anymore. Many projects asked for, if they could use Jenkins instead, and so some even evaluated Jenkins, and then we had to take actions and said, we cannot. We cannot administrate Hudson anymore or just support it anymore. We have to switch to Jenkins. And then we looked at ways to migrate from Hudson to Jenkins, which led to a little migration tool that we built, and that basically just transformed the configuration files from Hudson to Jenkins, because in those years there were some changes made, and so this had to be changed. Also, some custom scripts for our infrastructure were used, and this started or kicked off in late 2017, and we finished this process in early this year. And so now we don't have the Hudson instance per project initiative, but we call it Jenkins instance per project, JIPs. So there's no more Hudson instances since early this year. And this helped us a lot to give our projects more of a chance to use the current versions of plugins, and some plugins that were not even available for Hudson. But still, there were quite a lot of the projects using the JIPs. As of today, we have roughly 200 Jenkins instances, and we get more requests almost every day. They run on a dozen of quite powerful machines, but still, it's there are about 10 to 25 of Jenkins instances run on a physical machine, just bare metal, and this was quite easy to set up, but it had some limitations. We also have some, as mentioned before, we have some dedicated slaves, especially for Windows and Mac, but also for some projects that have more resource requirements. And just to give you a short overview of how we set that up, each project has its own service account, and this service account's home directory is stored on NFS. This home directory includes the Jenkins home, and each JIP is assigned to a certain machine where the jobs will run, except for when they run on slaves. And the jobs directory is actually not stored on NFS, but instead on the local disk, just for performance reasons. And this was, for let's say a limited amount of projects, it was quite nice to do that and quite easy to move around. But with 200 projects, we also reached our limits on how we could distribute the different projects over the physical machines. And so one of the positive sides of our current setup is that each project can customize their instance. Some projects even have their own release engineer, so they request from us that they can get admin permissions, and they basically run it themselves. And we would only help them if there's a special problem or some. In the worst case, we just have to flatten the instance and just rebuild it. Yeah, most of the projects rely on our support for handling, for example, installing a plugin or adding some configuration. Each project has with their own Jenkins instance, they have the advantage that they have the independent life cycle. So whenever they want to install something, they don't have to wait till other projects finish their jobs. They can just start and stop the instance or restart it from a little web UI in their Eclipse account. And there are lots of things that need improvement and that are not perfect in the current setup. So for example, the isolation between the projects. One single job from one project can consume all the resources, all the CPU, and affect other projects. And so we got some complaints every once in a while that the builds are slow and take 4 hours, and some timeouts are reached, and so on. And we also, as mentioned, most of the jobs are run on the master instance, apart from some jobs that run on slaves, which is considered a bad practice, so we want to get rid of that as well. And with this running on bare metal machines and distributing the projects across the machines, it does not really use our hardware that we have in-house to the full potential. And some machines are actually they're idling while other machines are just burning hot. And so yeah, this is not something that we or this is something that we want to improve. And we also have the build tools across all projects that are shared. They are shared on an NFS mount as well, but still they need to be synced and configured in the Jenkins UI. And this is administrative overhead, which we would like to get rid of. Also, increasingly over the last years, we got requests for Docker support, which we cannot provide on our current infrastructure. And so it became apparent that managing tens of Jenkins is quite easy. Hundreds of Jenkins becomes quite cumbersome and time-consuming. And we rather would spend our time to improve and add value to the services that we offer for our projects. For example, we want to improve digital signature and packaging services. We want to make it easier to deploy to Maven Central or our own Nexus server. We also want to provide additional services like static analysis tools, SonarQube, and similar things. And we also want to improve our integration with GitHub. And last but not least, we want to give our projects the best performance that we can have, and for that we would like to pool our hardware and use it more efficiently. We want to isolate the projects to a certain extent, so one project cannot hog the resources of another. And we want to add resources more easily, for example, in-house or from the cloud. And I don't know if you're aware, but this year it was announced that Oracle actually contributes the Oracle Java EE 8 and Glassfish technologies to the Eclipse Foundation. And this involves about 40 projects. And so especially for Glassfish and the TCK, the Technology Compatibility Kit, it will require a lot of resources just to build them. And so this was kind of the last nail in the coffin for our current setup. We knew that we had to step up our game. And that's where CGE, or now it's called Core, came into play. And Mikael will explain a bit about it.
Yeah, thank you. So it became clear that we needed something else. So we had two issues. Managing those hundreds of instances became too time consuming, and we wanted to pool our resources. So for that, we eventually came up with a duet solution. So to pool our resources, we switched to a Kubernetes cluster, actually running OpenShift. So for those who don't know, OpenShift is a Red Hat distribution of Kubernetes. And we also switched to CloudBees Jenkins Enterprise, or recently renamed as CloudBees Core. For those who don't know what is Jenkins Enterprise or CloudBees Core, it's basically a master of master. So it's what CloudBees call an operation center. So it's a special instance of Jenkins that will actually handle other masters. From this operation center, you can call and you can execute different operations on all or a given number of masters. From there, you can also provision your master. So here you get a screenshot of the provisioning UI. So as everything is running in Kubernetes, you will see some Kubernetes concept. But still, you can see that from a single UI, you can create a new instance very easily. And you can also execute what is called cluster operation on all masters. So for instance, you can batch upgrade all your instances that are managed by the operation center. Or you can also execute Groovy script on all the masters if you want to go somewhere the operation center is not yet providing a feature. So for it was very time consuming to do that all by hand or with custom scripts with the previous infra. The operation center is really a lifesaver on that point. The good thing with CloudBees Jenkins Enterprise is that it uses the Kubernetes Jenkins plugins, so all agents are actually dynamically provisioned inside the cluster. So we pool all those machines in a single cluster, and all the masters managed by the operation center will actually request an agent inside this cluster. Of course, you can still add dedicated agent to some masters. So for instance, if one master requires a very specific architecture or operating system that is not available as Docker images, for instance, AEX or a Windows machine, for instance, you can still do that. And you can also do what the operation center called share agents. So it's very handy for us for the most expensive slaves or agents, I would say. So we only have a couple of Windows and Mac machines available for all of our projects. And currently we have those agents attached to a shared instance. So projects need to have a job on this instance to get access to this agent. Now with the operation center, we attach those agents to the operation center, and each master can ask for a lease to the operation center for this agent. So master one wants to build on Mac, it takes the lease on the Mac machine. Nobody can use it anymore for the time the build runs, but then it releases the lease, and another master can ask it. So it's a very effective way to share slaves, agents, which are not compatible with Kubernetes. And the best thing of all is that we not only pool our resources for the agents, but also for the master, because everything is actually running inside the Kubernetes cluster. So the operation center itself, all the managed master by all the master managed by the operation center, and all the agents. So we benefit from all the features of Kubernetes. So the resiliency of the master. If something fails, it is restarted automatically. We get the monitoring stuff. All the monitoring tools available on Kubernetes that we can use for monitoring the system, and everything. All of that gives us a huge leap compared to our current solution. So of course, everything is not perfect in the world, and the migration to CG, we just started it back in June. So we already hit a couple of issues, and Frederick will demonstrate you a couple of them.
Yep.
and the workaround as well.
Okay, exactly. Is anyone currently migrating from open source Jenkins instances to CGE? Anyone? No. Okay. Well, if you at a future point might want to do that, I'll give you some things that some problems that we hit and or some challenges, and some possible solutions for it. So first of all, how do we move the jobs over? What needs to be moved? Obviously, job configurations, the views, some credentials, Maven settings. Maybe the build history would be a bonus as well. We don't want to move the build artifacts and anything. That's just that can be rebuilt, so it wouldn't be a problem. And so there's no built-in solution in CGE for mass migration of jobs. What they recommend, or what CloudBees recommends, is that you attach your open source Jenkins as so-called client master to the operation center. Then create a managed master, and then you can move or copy the jobs over from the client master to the managed master, which works for, I guess, for a limited number of jobs, but 200 projects with all their jobs, that's not going to scale. And so what we did is we created a little custom script, some bash is involved, that pulls or extracts the configurations, views, all that, zips it together. And then we use the tools from OpenShift, in this case OCRsync, to directly copy those files into the managed master pod. Unfortunately, the rsync tool is a bit limited because it only allows to move folders, not individual files. So it isn't perfect yet, and we still have to iron out a couple of issues and test it with more instances. But it should work, and it's a way to do it. As mentioned, we have to define Maven settings for all projects, especially for a proxy for Maven Central in our local Nexus instance, and also configure the credentials to access our local Nexus if projects want to deploy their artifacts to the Nexus. And fortunately, we found a nice plugin for that, the config file provider plugin, and it allows to store Maven settings. And in combination with the credentials plugin, it also allows to store them encrypted. So there's a but to it. I will get to that in a couple of slides. But first of all, how does it work with the normal Maven settings? As mentioned, you can just define your Maven settings in there. But for username and password, you should store them encrypted to a certain degree with Maven. And what Maven, especially the Maven requires so-called or master password to do that. And the master password has to be stored in a file called settings-security.xml. And there's no straightforward way to do that with a config file provider plugin. But as I mentioned, it provides support for the credentials plugin. And so you can define username and password in the Jenkins credentials, and then inject them into the Maven settings file dynamically. And this works fine, and is in that, or for at least for our Nexus instance, that works. But we also have the requirement for our projects to deploy to Maven Central. I don't know if anyone has done that before, deployed to Maven Central via OSSRH. Anyone? So for those who don't know, OSSRH is a service provided by Sonatype. It's called OSS Repository Hosting, and what it does is it allows anyone basically to deploy to Maven Central by providing a staging repository where you can upload your artifacts, and it runs a couple of checks. If those checks are successful, then it allows you to deploy to Maven Central. And to make this happen, you have to apply for an account, or you create an account on OSSRH. also with the credentials that you store in Maven settings. And another requirement is to sign the artifacts with GPG. And for GPG, you need the GPG keys and passphrase to protect it. And most projects, or one way to do it, is to use the Maven GPG plugin. And this plugin requires you to, or there are different ways of doing it, but I guess the most simple one is to store the credentials again in the Maven settings file. So they reuse the server credential facility that is already there, but they slightly change the way they do it. Especially, they don't use username and password, but instead use so-called passphrase tag. And this is not provided, or it's not supported in the config file provider. This was the but that I was mentioning earlier. And so we cannot use the config file provider plugin as mentioned with the credentials plugin, but instead we need to have a workaround. The workaround consists of, actually, it took quite a while for me to find out, but I mentioned that there's no straightforward way of doing it with or providing the settings security file in the config file provider plugin. Actually, you can still do it. You just use a Maven settings file, call it settings-security XML, and define the master password, encrypt it, and then inject this settings file into the .m2 directory. There's a way to do this with the option called provide configuration file. And what we do, because this is in the cluster environment, we inject it into the home directory of Jenkins, the Jenkins user, in the M2 directory. Next step is that we have to somehow store the GPG keyring. And there's a way to do this also with the credentials plugin, where you can store a secret file, in this case, the trusted keys GPG file. And this as well has to be inserted into the job. Unfortunately, you cannot do this the same as with the Maven settings security file. You have to use an option called use secret texts or files in that case, and you can only refer to it via a variable that links to a temporary file or a temporary folder where the file is then stored during the build. And what you need to do with a bash or with a shell step is then import this GPG keyring. It's important to specify actually the --batch argument. Otherwise, it does not work in a non-interactive way. And you also need to trust the keys, otherwise you get some error messages. So this is obviously, workaround and not the ultimate goal, but it doesn't stop there. A couple of iterations later, I found out that at least for newer versions of GPG, you actually have to add another option or argument that makes it work. So this is this pin entry mode loopback. Last but not least, you have to define the settings file in your Maven build step where you store your passphrase. That's for the Maven or for the GPG setup, and I guess this will not be the last way to do it, but it's a workaround for now, and we will use it in the beginning, and maybe there will be other solutions to it. So if anyone has other ideas how to do it, feel free to talk to me, and I would be interested. So another request that we have, or another requirement that we have, is many of our projects at Eclipse, they don't store their repos on GitHub, but on our own Gerrit instance, and make heavy use of the Gerrit trigger plugin to trigger their builds. And for this, there needs to be authorization, and SSH keys need to be stored. And what we used to do is we stored them in the user home directory. This does not work in our environment, in the cloud environment or in cluster environment. And so there are already some tickets for that open. One ticket actually suggested to, also as a workaround, to store the SSH keys in the Docker image for the managed master, which is, I guess, possible, but also not something that we would want to do for the rest of the time. And so we will look into maybe patching the Gary Trigger plugin and contributing some changes to make it available or to make it compatible with the credentials plugin, because that's what's missing. Apart from that, from those configuration issues, obviously we are still quite new to the whole Kubernetes and cluster environment, and we're learning every day. And we had some stability issues in the beginning, but thanks to the great support from CloudBees, it was really responsive and really excellent. We were able to improve that situation, and now our cluster is much more stable. And we are looking forward to what actually will happen when the projects run their builds on it, and when we see the thing actually starting to fly. So for our roadmap, as Mikael mentioned before, we started in June this year, and we set up the cluster. Since August, we kind of onboarded early adopters, some projects that said they want to test it and provide us feedback. And the mentioned Jakarta EE projects that are now onboarding, and 40 projects at one time with a deadline that is coming up quite soon. So we are now in full onboarding mode and providing new JIPs for them. And this is like the main priority at the moment. But all our other projects should be migrated or we're aiming for early 2019 to make that happen. With that, I guess we can take some questions.
Yeah.
Do you guys have OpenShift experts in-house? Were you running it already, or what was the adoption of that, and why?
So the question was, do we have any OpenShift expert here in-house? No, we learned it by the hard way. Our IT team, actually, so Frederick and me, we both are more involved on the build side of the infra team, and there are two other persons in Ottawa who are actually more involved on the hardware part and network management, who actually dealt with the OpenShift part. So they learned it the hard way following Red Hat documentation.
Yeah, on the job. Any other questions? Yep.
Your decision to have one project for Jenkins, is that what you said? I came in a little late, but
yep.
Do they, at that point, do you hand that off to that team, that project team, and they can add whatever there, or is there certain guidelines that they have to collaborate with?
So yeah, it depends a bit. Some projects, as I mentioned, they have their own release engineer, and so they can, we give them admin access, and so they can just basically do whatever they want. They can customize it, they install their plugins, and do whatever they want. For other projects, that, for example, don't have their own release engineer, they rely on our support, and we help them get going, and whenever they have to install something, they have to open a ticket, and we'll do it for them. So,
quick follow-up question: like, how do you manage backups? Like, if some project behaves badly, say, and they install a bunch of plugins that don't play right, and they can't figure it out, and come back to you guys and say, "Can you fix this?" Do you have to investigate, what that issue is, and how do you maybe spin them back up?
As soon as we give them administrative permission, admin permission, we tell them that, okay, you're on your own.
Yeah, so in that case, we would just flatten them and just rebuild in the worst case. But obviously, we will, before that, we will try to help them and try to, like, say, investigate and remove something. But yeah.
We still run backups, but in the event of something really bad happens, we can only restore what we have.
Yep.
You guys consider using OSS under OpenShift, or what was the reason
So yeah, we thought about it while investigating what are our options for making this possible or making it future-proof. But we ended up with deciding that we would like to rely on the support from CloudBees and to have people that actually, let's say, know how to do that on that scale, and yeah, not spin up our own do-it-yourself method. That was kind of the most pressing reason.
Yeah, the operation center was also one of the stuff that we wanted. Of course, there are other solutions. We could use Helm charts to cookie cutter several masters and stuff like that, but we wanted to rely on something a bit more mature and on which CloudBees were able to provide us support. As we said about OpenShift, we were already running Kubernetes and OpenShift, so everything on our own was, with the deadline we had, especially for onboarding the new projects, it seems not reasonable.
Any other questions? Yes?
How do you handle upgrades?
So in our old infrastructure, this was actually quite a pain. When, as I said, we had 200 instances, and there was a security update not too long ago, or security issue. We used, in that case, we used the init Groovy script that we deployed to all the instances and restarted them. Turns out that it did not work quite that well. We had to, in the end, still look at every instance and check, because we had some special requirements that, for example, one plugin should not be updated due to regressions. And it turned out that sometimes it still got upgraded, sometimes it didn't. And so, yeah, this was a pain and took a lot of time. And so we're really looking forward to do that now with on CGE with such a cluster operation to upgrade it in a batch and hopefully see without that much pain. That's also one of the things that CloudBees actually provide with Jenkins Enterprise or CloudBees Core is the Beekeeper program. So they give you update site or update center with only validated set of plugins. So you know that when you upgrade from one version to another, you also upgrade with a new set of plugins that are said to be compatible or have been validated by CloudBees. Doesn't mean that nothing bad will ever happen, but it provides some insurance. Yeah. Okay. Yes.
Have you had to load balance Jenkins at all, where you have one code base that generates so much CI load, it's overwhelming the amount of capacity that one master can take?
Not so far. And I guess, as I mentioned, there will be lots of load coming with, for example, a Glassfish project. And we would like to just distribute that to slaves, and that's kind of the best practice. Instead of having one master that does that, just spread the load to the slaves in the cluster. And that's kind of our solution, or hope that we can do it with that. Yeah. Any other questions?
But do y'all manage the slaves as well for them, or
Depends. We have some projects that bring in their own slaves. They have some machines, let's say, in their company, and we can hook them up externally. That's how it's done right now in our current infrastructure. We would probably offer that option in the new environment as well. We will, since this is kind of more dynamic and we can add more slaves and more resources more easily, that's what we want to bring to the projects as service as well.
So are the majority of the slaves the persistent ones are a pretty small number, or is that a lot of them that are persistent?
It's a small number.
Yeah. Currently, it's quite a small number, yeah.
Most of the dedicated agents are actually provided by the project on their own. We only provide the Windows and the Mac OS machines by ourselves. But we only provide a couple of
a few others
different agents. But
for UI tests, there's one, I mentioned the performance master that we had in the beginning. This was replaced by a slave as well, for example. But we'll probably, for projects that require them, we hopefully be able to do that with the new environment more easily. Yeah.
But you haven't had to address anything with jobs. That's entirely on the projects and managing jobs
That in most parts, yes, to the extent that some project says, well, nothing works, fix it, and we have to check and see, well, is that the problem caused by the infrastructure or by the job configuration? And we will obviously, as this becomes more popular, we will recommend pipelines to projects in the future to make this another possibility to run their jobs. But as of now, a lot of projects are still just using freestyle jobs. And we will not do this all in the same time with migration. We'd like to just start migrating first and then recommend this as a best practice later on.
One of the goals of spending less time on administrating this whole infrastructure is to actually be able to provide best practices to our projects. Yeah. So we hope to be able to do that soon. There was another question there. Maybe a last one.
Small point that you made earlier. Do you have worker nodes that are being contacted by multiple masters?
Can you repeat the question?
It sounded like you had worker nodes or slaves. I tried to say worker nodes that are being used by multiple masters. Do you still do that?
No, we don't do that anymore. Actually, we never had any agent that were used by several masters.
It was a point. It kind of went by real quick, so I just wanted to clarify.
Yeah. Any other questions? Yeah.
How do you do the Jenkins home backup?
This is, for now, it's a custom solution, but we're working on, together with CloudBees to more automate that,
Yeah. So on the old infra, the Jenkins home were on NFS, so we are backupping the NFS the NFS folder where all the Jenkins home were in. On the new instance in OpenShift, the persistent volume are also coming from NFS, so we just back up the NFS folder as like we were doing before. But the Operation Center is actually providing a backup feature, but we cannot use it yet because there is some incompatibility with OpenShift. It works on Kubernetes, but not on OpenShift because of some discrepancies between the two. So we are waiting for it to be fixed before we can use it.
Any other questions? Yes?
For the images that you run for the masters, for example, do you use like the catalog from Red Hat? Do you use images from Docker Hub, or do you use Open GDK and just install Jenkins on it?
So the images are actually provided by CloudBees. So that's official CloudBees core managed master images that we can customize it. It comes pre-built with a couple of proprietary plugins, and also the plugins that actually let the master to communicate with the Operation Center. So there are a couple of features that comes with the whole CloudBees core suite. For instance, you have a single sign-on between masters because it all goes through the Operation Center and stuff like that, and it's provided by the image. So you cannot really use the bare of the images that you can find on the Docker Hub and stuff like that.
Yeah. So yeah, if you have any more questions, then sure we'll be around.
Yeah. So just as a quick key takeaways from this talk, so our issues were obviously to diminish, to lessen the time that we spent on managing all those instances, and of course to scale the usage, the resources that, to be able to better use the resources that we have. And for that, we went for the two solutions. So switch to CGE for to spend less time, on administration, and to Kubernetes to better use our resources. But the main issue actually that we face from this migration is moving from the stateful build agents that we used to have to stateless. So I guess that anyone who is moving to Kubernetes or stateless agents will face common issues that we have. So if you have some question and some solutions for this migration, please feel free to come back to us. We'll be there until tomorrow. Thank you very much. Yep. Oh, don't forget to evaluate the talks, not only this one, but all the others. It's important for the conference and for the speaker to know what you thought about it.
Nintendo Switch.
Thank you. Bye.